Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 53 of Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I'm Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. Did you know that 2023 is the International Year of Millets? That's a UN designation declared by the United Nations General Assembly. The idea behind it is to raise awareness of the nutritional and ecological benefits of millets and to promote their production and consumption. Sounds great, but what exactly is millet? It's a catch-all term for a really varied group of small seeded grasses, widely grown around the world as cereal crops for food or fodder. Almost all millet production takes place in the developing world because these annual grains have a short growing season and thrive in hot, dry conditions. Sorghum and pearl millet are the most widely grown. You may also have heard of finger, proso and foxtail millets. Humans originally domesticated millets in Asia and Africa and have been eating them for about 7,000 years. They're gluten-free and nutritious, yet their diversity is in peril in a world where corn, wheat and rice dominate. Wood millets make good crops for growing in space. Pearl millet is the most widely grown type, making up around half of Earth's millet production. It produces ovoid grains, 3 to 4 millimetres in length, which come in a variety of colours from white and pale yellow through to grey, brown and even purple. Different types vary in height, from a manageable half-metre tall to 4 metres. Pearl millet is adapted to drought and low soil fertility and performs well in high salinity and at high pH. So far, so good, but it likes high temperatures which may be harder to provide in space. However, it sounds as though there's plenty of potential there for breeding varieties that would thrive in space and on the Moon or Mars. On Earth, pearl millet is used for flatbreads and porridges, both of which could be a useful addition to the diet of off-worlders. Moving on to sorghum, there are about 25 different species worldwide, with 17 of those native to Australia. Humans first domesticated sorghum in what is now Sudan more than 5,000 years ago. The main agricultural species is sorghum bicolour. Varieties can have an outstanding range of uses. In India, pop sorghum is a popular snack similar to popcorn but with smaller grains. Malted sorghum behaves very like malted barley, so it can be used to produce beer and other alcoholic beverages. I've always been fascinated by sorghum, which isn't grown much in the UK except to provide cover for game birds. But in the US there are varieties producing sweet sorghum syrup, also known as sorghum molasses or sorgo, and varieties with stiff stems grown as broom corn. Apparently you need about 60 heads of broom corn to make a decent broom, but people these days are more likely to use it for crafts and flower arranging. It looks like even the dwarf varieties of sorghum are at least a metre tall, and it does have one other drawback in that stressed plants can produce hydrogen cyanide and other toxins, so sorghum may not be a natural choice for a space crop. However, it does have enormous potential for feeding people as Earth's climate warms, and space breeding could help develop new varieties. I'm going to pause here for a second to say a big thank you to all my Gardeners of the Galaxy boosters. Every spaceship needs fuel to stay in orbit, and Gardeners of the Galaxy is no exception. My rocket boosters support the show financially, and there are several ways to do that. Just as important are my signal boosters, who help me expand the Gardeners of the Galaxy community by following me on social media and liking, sharing my posts, or by leaving reviews in their podcast apps. You can find out more about becoming a booster by visiting theunconventionalgardener.com/boosters. When seeds are sent into space, they can be affected by the space environment, microgravity and cosmic radiation. This can change the DNA inside the seeds, causing mutations that might develop into new characteristics such as drought or disease tolerance. Space breeding, also called space mutagenesis, takes advantage of those changes, but scientists back on Earth still have to screen the plants for useful changes and then breed them into new varieties. Space breeding just speeds up the first stage, producing more mutations more quickly than would naturally occur on Earth. As I've mentioned before on the show, China is heavily invested in space breeding and has been using the technique since 1987. China is the only country currently using space breeding to develop new crops. It released its first space-bred crop, a type of sweet pepper, in 1990, and China's second most widely grown wheat variety was also developed through space breeding. China is currently the leader in space breeding, but the technique dates back to the early days of space travel. NASA and the Soviet Union both conducted space breeding experiments, but Western scientists have remained sceptical as to its benefits. Exposing seeds to cosmic radiation is essentially very similar to nuclear mutagenesis, which exposes seeds to radiation here on Earth. We've been doing that since the late 1920s, bombarding seeds with gamma rays, X-rays and ion beams. We've learned that different species have different tolerances to radiation. The trick for nuclear mutagenesis is to use the right dose. Too small a dose won't produce any changes, while too high a dose will kill the seeds. Controlling the dosage is much easier to do on Earth, of course, than it is in space. Nuclear breeding programs were popular in developed nations by the 1950s, but while they led to the development and release of many new varieties, scientists here have turned their attention to genetic modification instead. That involves directly modifying the DNA of a plant rather than hoping a suitable modification arises naturally or can be induced. However, nuclear breeding didn't go away and remained popular in Asia-Pacific, and now the International Atomic Energy Agency's database of mutant crop varieties has more than 3,300 entries. So with these techniques well established on the ground, why is there a need to send seeds into space, especially when space payloads are so limited? Chinese scientists say they see more beneficial mutations in seeds that have been to space compared to those that are artificially irradiated on Earth. The difference could be due to the nature of the exposure, with one brief strong dose on Earth compared to a much longer exposure to lower doses in space. The race is on to develop new crops able to adapt to Earth's rapidly changing climate, and it makes sense to use all of the tools available to us. That's why the International Atomic Energy Agency and the Food and Agriculture Organization of the United Nations launched seeds into space in November 2022. In November 2022, the NG-18 resupply mission carried 2 seed payloads to the International Space Station on behalf of the International Atomic Energy Agency and the Food and Agriculture Organization of the United Nations. The 2 payloads are part of a feasibility study to investigate the extent of genetic variation induced by cosmic radiation and microgravity, and whether space breeding can help develop new crop varieties able to withstand the increasingly harsh growing environments on Earth imposed by climate change. Both payloads use 2 different plant species, the model plant Arabidopsis and sorghum. Both species were chosen because a large bank of scientific data is already available for comparison. In one payload, the seeds were kept inside the ISS for the duration of the mission. In the other, the seeds were split between the internal and external environments of the space station. After spending around 5 months in space, both payloads returned to Earth in Cargo Dragon CRS-27 last month. The seeds then returned to the labs at the joint FAO-IAEA Centre in Siebersdorf, Austria, where researchers will screen and analyse them for desirable traits. Part of that analysis will compare the space-flown seeds with control seeds that stayed on Earth and were exposed to different types of radiation. The scientists will be extracting and sequencing DNA from all of the seed batches to uncover any changes between those irradiated in the lab, the ones that stayed in relative safety inside the ISS, and those that had a 5-month spacewalk. The seeds will be grown onto the next generation before trait selection, and the first results for the faster-growing Arabidopsis could be available as soon as October. As far as I can tell, these are the only space experiments conducted with millets, but I think that as more and more countries venture into space, we'll see more diversity in the plant species flown, both for experiments and in space food. That's it for this episode. I'll put some links to further reading about space breeding in the show notes, which you'll find at theunconventionalgardener.com. Thanks again to my boosters for supporting the show. Don't forget that you can sign up for the Gardeners of the Galaxy newsletter for new episode alerts and bonus astrobotany content. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control, confirming termination of your signal. We've heard from Mark Watney and he'd love to visit for dinner in the Space Garden. However, he does have a concern about the menu. Apparently he's sick of potatoes. Mission Control out.